Welcome to clickmyproject.com. Here we discuss about error rate analysis of CR transmission network with imperfect channel sensing. Cognitive radio network, which is most widely used in multi-input, multi-output applications. The transmission spectrum, when the audio and video signals are integrated into a single mode, that several transmission schemes prefer to sense the bandwidth frequency range of the entire system. There are two prominent use of spectrum sharing schemes would be preferred. One is opportunistic spectrum access, another one is sensing based spectrum access. In both schemes, secondary users perform the channel sensing. In SSS, that is spectrum sharing sensing, the secondary transmission power would be allocated based upon the decision, and in opportunistic spectrum access, the secondary users are allowed only if the primary users are not activated. The channel sensing consider two cases. One is without power constraint and another one is with power constraints. The third process is the channel model creations. There are four cases in the channel model creation depending upon the two parameter. One is busy and another one is ideal. The optimal decision rule based upon the channel model is also proposed to estimate the error performance of cognitive transmission system. So, perfect channel sensing, imperfect channel sensing, without power constraint, with power constraints. These are all the cases to be validated in this paper. Next we discuss about the system architecture of our proposed system. So the architecture consists of 6 major blocks. They are all channel sensing, power and interference constraints, cognitive channel model, optimal decision rule, error rate analysis, average symbol error probability evaluation. Channel sensing. Here the secondary user perform channel sensing, which is modeled as hypothesis testing problem. The energy detection matching filtering process errors are detected in this module. Power and interference constraints. Here the average power is P0 if no primary user transmission occur. Then the imposing of interference constraints to the module and evaluated the average power again. No transmission is allowed if the channel is sensed as busy. Cognitive channel model. This is the third module. There are 4 cases in this module. The busy channel sensed as busy means that is the first case. The busy channel sensed as ideal state, this is second case. The third case will be ideal channel sensed as busy. Fourth case, ideal channel sensed as ideal. So depending upon these 4 categories, optimal decision rule is made. Using this optimal decision, the error rate analysis, symbol error probability has to be estimated for various number of users, that is signal to noise ratio values and modulation techniques. So perfect imperfect channel sensing, the comparative analysis are made here. Next we are going to discuss about the running procedure of our proposed system. So running procedure consists of 2 functions. One is main function and another one is sub function. The main function declares the constant parameters needed for the channel model creations, that is number of frequency bands, number of users and simulated time instance. They are all declared here. And also power constraints, average power constraints, channel interference selections, they are all declared in this main function. After declaration, the cognitive CRC subfunction called. This subfunction returns the channel state information of, that is power, current, actual interference, estimated interference, angle calculation, sample power, sample current, interference power, they are all returned. So this subfunction receives the commands, that is constant values declared in the main program, such as frequency bands, number of user, simulation time instance. They are all declared from the main program. So here the calling function is over. After the calling function, this cognitive CRC subfunction returns the parameter of power estimation values for channel state information. Perfect imperfect channel sensing has to be declared first. So the secondary channel state information is calculated first, and primary channel constraints for the secondary channel interference are estimated here. The mean and variance values are calculated and then returned to the main function. The estimated interference of channel creations are calculated here. The instantaneous power value, current value, power sample values are calculated in this cognitive CRC functions. After the calculation, it returns the main program. In the main program, the collection of all the parameters such as error performance, symbol error probability estimation are estimated. The actual mean square error and standard deviation error performance are collected from the subfunction, and it is to be displayed in the figure window. The estimation of error technique involves two schemes: opportunistic spectrum access, sensing based spectrum sharing access. So for these two schemes, the error rate are calculated and displayed in the separate windows. Now I run the main program. The figure 1 shows the actual imperfect mean estimation of real part imaginary part of the error rate performance, and the figure 2, it shows the comparative analysis of opportunistic spectrum access and sensing based spectrum access of average symbol error probability with the probability of detection. The probability of detection, it returns the false alarm status when the channel is busy. And in figure 3 shows the variations of maximum to minimized variation of opportunistic spectrum access when the probability of false alarm is detected. And figure 4, it shows the comparative analysis of modulation technique with average symbol error probability is estimated here. Thank you.